Earth, 4 billion years ago, was nothing like the world we know today. It was a planet in chaos, a barren, violent wasteland dominated by extreme volcanic activity and relentless asteroid impacts. Rivers of molten rock stretched across the surface, and towering volcanoes spewed toxic gases into the thick, choking atmosphere. There were no oceans, no continents, only an endless expanse of fire and destruction. Above, the sky was a battlefield. Giant asteroids and comets, some as large as cities, rained down in an event known as the Late Heavy Bombardment. These impacts were so frequent and so powerful that they reshaped Earth's crust over and over again, leaving behind vast craters and deep scars. Each collision released unimaginable energy, vaporizing rock and sending plumes of molten debris back into space. Some of this debris would fall back to the surface as fiery meteor showers, while others drifted away into the void, lost forever. Amid this devastation, something crucial was happening, something that would determine the fate of Earth for billions of years to come. With every impact, asteroids and comets brought with them essential ingredients for life: water, carbon, and organic molecules. As the planet cooled, these elements began to settle. Trapped beneath thick clouds of steam and gas, the first traces of liquid water started to form. At first, they were nothing more than small pools, quickly evaporating under the scorching heat. But over millions of years, a transformation began. Volcanic eruptions continued to shape the landscape, but now they were releasing something more than just fire and destruction. Deep within the planet's crust, chemical reactions were producing vast amounts of water vapor, which slowly condensed and fell as rain. For the first time in Earth's history, a new force was at play: the formation of the first oceans. As the relentless downpours continued, the scorching, rocky surface gave way to massive bodies of water covering much of the planet. This was the beginning of something extraordinary. But Earth was still far from habitable. The atmosphere was thick with carbon dioxide, methane, and sulfur, creating a greenhouse effect that kept temperatures high. Without oxygen, the skies were an eerie, hazy orange, and the oceans were dark, filled with dissolved minerals that made them look nothing like the clear blue waters we see today. It was an alien world, harsh and unforgiving, yet full of potential. For the next few 100 million years, Earth would remain a planet in turmoil. But hidden beneath its turbulent surface, in the depths of its newly formed oceans, something remarkable was beginning to stir: the first signs of life. The next chapter in Earth's history was about to begin. As the relentless downpours continued for thousands of years, water pooled into vast depressions on the planet's surface, forming the first primordial oceans. But these waters were nothing like the crystal-clear seas we see today. Instead, they were dark, murky, and filled with dissolved minerals, a reflection of the chaotic planet they formed on. The heat from Earth's molten interior kept these early oceans boiling, and hydrothermal vents at the ocean floor spewed superheated water, rich in chemicals that would one day prove essential for life. Above, the sky was an eerie shade of deep orange and red, thick with swirling clouds of methane, carbon dioxide, and sulfur. The air was toxic, completely devoid of oxygen, making it impossible for anything resembling modern life to survive. This was Earth's first atmosphere, but instead of being a cradle for life, it was more like a suffocating blanket, trapping heat and creating an intense greenhouse effect. At this stage, Earth was more similar to Venus and Mars than the blue planet we know today. Venus, with its thick clouds of carbon dioxide and scorching surface temperatures, represents what could have been if Earth had become too hot. Mars, a dry, barren wasteland, shows the fate Earth might have met if it had lost its water to space. Strangely, our world sat between two extremes, walking a thin line between habitability and complete desolation. For millions of years, Earth remained a hellish world, hostile and unrecognizable. But deep within its turbulent oceans, a quiet revolution was about to begin, one that would set the stage for the emergence of life. The planet was still on the brink of destruction, but within its churning waters lay the first whispers of something extraordinary. Beneath the surface of a world still ruled by fire and chaos, something extraordinary was about to unfold. Deep within the murky, mineral-rich waters of Earth's first oceans, the building blocks of life were coming together in a process that would shape the fate of the planet forever. These lifeless waters, once formed from the steam of ancient volcanic eruptions and the icy remnants of asteroids, now held the potential for something more, something unprecedented. But life would not begin in the open ocean. Instead, it would emerge from the darkest, most extreme environments on the planet, the hydrothermal vents of the deep sea. These towering, chimney-like structures dotted the ocean floor, spewing superheated, mineral-rich water into the cold depths. Here, amid the intense pressure and complete darkness, Earth's first chemical reactions for life were taking place. Unlike the world above, where asteroid impacts still battered the surface, the environment surrounding these vents was eerily stable. The superheated water, filled with iron, sulfur, and other essential elements, created a chemical playground where the impossible was slowly becoming possible. In this alien world, strange chemical reactions were taking place. The hot, mineral-rich fluids from the vents interacted with the surrounding seawater, triggering complex organic reactions. Among them were the formation of amino acids, the very foundation of life itself. These tiny molecules, carried by the currents, began to form more intricate chains, proteins, lipids, and the first precursors to genetic material. The first microscopic life forms, simple and primitive, began to take shape. They were microbial organisms, no more than single-celled bacteria, but they were unlike anything the universe had ever seen. These microbes, known as chemosynthetic bacteria, didn't rely on sunlight for energy. Instead, they harnessed the chemical energy from the hydrothermal vents themselves, feeding on sulfur and other elements spewed from the Earth's depths. It was a completely different way of sustaining life, one that would allow organisms to thrive in places once thought impossible. For millions of years, these simple life forms remained hidden beneath the waves, multiplying, adapting, and spreading across the ocean floor. Slowly but steadily, they began shaping the world around them. Some clustered around the vents, forming strange, alien-like colonies. Others drifted with the currents, seeding the young oceans with life. With every passing generation, new variations emerged, some more efficient at processing minerals, others developing protective layers to withstand the hostile conditions. But the most profound transformation of all was yet to come. Among these ancient microbes, a special kind of bacteria would arise, one that would forever change the course of Earth's history. These were the ancestors of cyanobacteria, organisms that would go on to achieve something revolutionary, harnessing the power of the sun itself. Though they were still far from dominating the planet, their eventual rise would trigger a chain reaction that would make Earth truly habitable. But that moment was still billions of years away. For now, Earth remained a world of extremes, a planet covered in fire, water, and endless storms. Above, the sky remained thick with methane and carbon dioxide. Lightning flashed through the dense atmosphere, igniting violent storms that raged for centuries at a time. The land, barren and lifeless, was nothing more than a wasteland of cooling lava fields and volcanic craters. If an observer had looked upon Earth at this stage, they would have seen a world that looked more like an alien planet than the home of future civilizations. Yet, despite the overwhelming hostility of this world, life had taken its first step. It was fragile, microscopic, and vulnerable, but it had begun. And once life had found a way to exist, it would never be stopped. Over the next billions of years, these microbes would evolve, diversify, and ultimately transform the planet in ways no one could have imagined. The road ahead would be marked by catastrophic extinctions, incredible adaptations, and the rise of creatures beyond comprehension. But for now, in the darkness of the deep, the first tiny organisms clung to existence, unaware of the incredible journey that lay ahead. Earth was no longer a dead world. The spark had been lit, and soon that spark would grow into a force powerful enough to shape the destiny of the entire planet. For millions of years, life remained hidden beneath the surface, thriving in the darkness of the ocean depths. Primitive microbes clung to existence, feeding off the minerals spewed from hydrothermal vents. But deep within these waters, a revolutionary organism had emerged, one that would change the fate of Earth forever. These were cyanobacteria, microscopic but powerful, capable of harnessing the energy of the sun itself. Unlike their predecessors, which relied on chemical energy from the deep sea, cyanobacteria had developed a groundbreaking ability: photosynthesis. They absorbed sunlight, using its energy to convert carbon dioxide and water into food. But in doing so, they created something entirely new, something that had never existed in abundance before: oxygen. At first, this oxygen had no place to go. It reacted with iron dissolved in the oceans, creating vast deposits of rust-colored minerals that would later form the iron-rich rocks we see today. For millions of years, Earth's oceans slowly changed color as oxygen bound itself to the elements in the water. But eventually, the iron was used up, and something unprecedented happened. Oxygen began escaping into the atmosphere. To the microbes of the ancient world, this was a catastrophe. Oxygen was a highly reactive, toxic gas, and for most anaerobic life forms, it was lethal. Entire microbial colonies perished in what became one of the earliest mass extinctions in Earth's history. But for cyanobacteria, this was just the beginning. They flourished, multiplying across the planet's shallow waters, filling the atmosphere with oxygen. The very gas that had once been deadly was now reshaping the world. Over millions of years, Earth underwent a profound transformation. The once thick atmosphere, dominated by methane and carbon dioxide, began to clear. The sky, once an eerie orange, slowly turned blue. The murky, iron-rich oceans became more transparent, revealing the rocky seabed below. And with more oxygen in the air and water, life had the chance to evolve in ways never before possible. This event, now known as the Great Oxygenation Event, was a turning point in Earth's history. It marked the beginning of a new era, one where oxygen-breathing life forms could begin to emerge. But it would also bring about one of the planet's first great environmental crises. As oxygen levels rose, they triggered the planet's first ice age, plunging Earth into a frozen world unlike anything seen before. Yet, despite the challenges, life endured. Cyanobacteria had reshaped the planet, paving the way for more complex organisms to evolve. The once hostile world was becoming more hospitable, setting the stage for an explosion of life that would eventually lead to the rise of the first multicellular creatures. The long road to complex life had begun, and the world would never be the same again. For hundreds of millions of years, Earth's skies were thick with methane, its oceans rich with dissolved iron, and its life forms simple and microscopic. The planet was stable in its own hostile way, until something changed. Deep in the shallow waters of primeval seas, cyanobacteria had found a new way to survive. Unlike the primitive microbes that came before them, these tiny organisms had unlocked the power of photosynthesis, using sunlight to create energy. But in doing so, they unleashed a force that would reshape the world: oxygen. At first, the oxygen produced by cyanobacteria was harmless, dissolving into the ocean and bonding with iron to form rust-like deposits on the seafloor. Layer upon layer, these deposits accumulated, creating what we now call banded iron formations, some of the richest iron ore deposits in the world. But over time, the iron in the oceans ran out. Oxygen had nowhere left to go, so it began to flood the atmosphere. This was a catastrophe for most life on Earth. For the first time, vast amounts of free oxygen filled the air, creating an environment toxic to anaerobic organisms, the microbes that had dominated the planet for billions of years. These ancient microbes had evolved in a world without oxygen, relying on methane and sulfur to survive. But now, their very existence was threatened. Oxygen was a highly reactive gas, attacking and breaking apart the delicate chemical bonds that sustained anaerobic life. Entire microbial ecosystems collapsed in what became Earth's first mass extinction event. The very organisms that had once thrived in Earth's early environment now faced near total annihilation. This was the first great purge of life, a cruel twist of fate where nature itself had become the executioner. For the survivors, Earth was no longer the world they once knew. The delicate balance of gases in the atmosphere had been shattered, and with it came another consequence, one even more devastating than the loss of life. As oxygen levels rose, they reacted with methane, a powerful greenhouse gas that had once trapped heat in Earth's atmosphere. With methane levels plummeting, the planet began to cool at an alarming rate. Within a few million years, global temperatures plummeted, triggering one of the most extreme ice ages in Earth's history. This event, now known as Snowball Earth, was unlike anything before or since. The drop in temperature was so dramatic that ice sheets rapidly advanced from the poles, covering the planet in a frozen grip. Once thriving oceans turned into vast fields of ice, stretching all the way to the equator. From space, Earth was a blinding white sphere, almost unrecognizable from the volcanic world it had once been. The very engine of life seemed to sputter and slow, buried beneath miles of ice. Life was pushed to the brink. The very organisms that had triggered this transformation now found themselves struggling to survive. Only in the warmest regions, near hydrothermal vents and beneath the ice-covered seas, did life persist. Cyanobacteria, the architects of this catastrophe, continued to exist in isolated pockets where liquid water remained. But the dominance of anaerobic life was over. This was the beginning of a new Earth, one that would favor organisms capable of adapting to oxygen. For millions of years, Earth remained frozen, locked in an icy prison. The cold was relentless, and the planet saw little respite. However, volcanic activity beneath the surface never stopped. The churning of molten rock deep within the Earth released vast quantities of carbon dioxide into the atmosphere, slowly building up over time. This carbon dioxide, another greenhouse gas, began to trap heat once more. The balance started to shift. Gradually, the ice began to retreat, and the oceans thawed. The once white planet darkened as rock and water were exposed once more. The Snowball Earth era had come to an end, but the world it left behind was forever changed. The landscape was now reshaped by glaciation, and the survivors had endured one of the greatest challenges in Earth's history. The lessons learned from this frozen apocalypse would be imprinted into the DNA of future life, ensuring that resilience and adaptation became key traits of survival. With oxygen now a permanent feature of the atmosphere, the stage was set for the next great leap in evolution. More complex life forms would soon emerge, organisms capable of using oxygen to fuel their metabolisms, leading to greater energy production and, eventually, the rise of multicellular life. What had begun as a catastrophe had become an opportunity, setting the foundation for the world as we know it today. The Great Oxygenation Catastrophe was Earth's first extinction-level event, but it would not be the last. Over the coming eons, life would face many more challenges: asteroid impacts, supervolcanic eruptions, and more ice ages. And yet, each time, life found a way to endure, adapt, and evolve. The planet had been reborn, but its greatest transformations were still yet to come. The story of life was just beginning, and the struggles of the past would shape the triumphs of the future. For millions of years, Earth's first great catastrophe continued to unfold. The rise of oxygen, once an invisible and silent threat, had reshaped the planet's chemistry, atmosphere, and climate. The very organisms that had triggered this transformation, cyanobacteria, were now among the few survivors. Life had inadvertently set in motion a chain reaction that nearly led to its own annihilation. As Earth remained frozen in its snowball state, survival was pushed to the extreme. The vast ice sheets covered nearly all of the planet's surface, reflecting sunlight back into space and preventing any significant warming. Beneath this icy shell, the oceans were locked away, their once thriving ecosystems now silenced. The cold, combined with the oxygen-rich environment, had wiped out almost all anaerobic life, the dominant form of life on early Earth. Only the most resilient organisms, those that could withstand extreme conditions, managed to cling to existence. Deep in the ocean, at the bottom of the abyss, life found refuge in one of the most hostile environments on Earth: hydrothermal vents. These fissures in the seafloor, where magma-heated water erupted into the dark ocean, provided a last sanctuary. Here, in complete darkness, life continued to thrive. Chemosynthetic bacteria, which derived energy from sulfur compounds instead of sunlight, supported entire ecosystems. Giant tube worms, blind shrimp, and other bizarre creatures clustered around these vents, forming some of the last remaining pockets of life on Earth. It was a world unlike any other, where survival depended on Earth's internal heat, rather than the light of the sun. Even in such harsh conditions, nature found a way to persist. In addition to hydrothermal vents, liquid water existed beneath the thick ice sheets in isolated pockets, where microbial life endured. Some of these ancient microorganisms would later give rise to new forms of life, adapted to an oxygenated world. Evolution was now being driven by an invisible force, natural selection under extreme pressure. But life was not yet out of danger. The oxygen-rich atmosphere, combined with the frigid climate, had drastically altered Earth's geological processes. With most of the planet frozen, weathering of rocks slowed to a near halt, preventing the cycling of vital nutrients. This led to long periods of stagnation, where even the most resilient organisms struggled to find the resources needed to survive. Extinction rates soared, and for the first time, it seemed that the very existence of life itself hung in the balance. Yet, in the face of near-total extinction, life had one final advantage: time. The geological clock continued to turn, and deep beneath the frozen surface, Earth's internal heat refused to be silenced. Volcanic activity persisted, releasing carbon dioxide into the atmosphere. Over millions of years, this gradual accumulation of greenhouse gases began to warm the planet once more. The thick ice sheets that had smothered life for so long began to crack and retreat. Slowly, Earth awakened from its deep freeze. As the glaciers melted, oxygen continued to shape the planet in unforeseen ways. With the return of open oceans, new ecosystems emerged. The survivors, those few species that had endured the nightmare of Snowball Earth, became the ancestors of all future life. The world that came next would be unlike anything before. Oxygen had set the stage for an evolutionary explosion, one that would eventually lead to the rise of complex organisms, and much later, the first animals. The near-total collapse of life had been a turning point. It was the moment when Earth could have become another lifeless rock drifting through space, much like Mars. But instead, it had set the foundation for everything that would follow. Life had survived its greatest challenge yet, but even greater transformations lay ahead. The story of Earth was far from over. For billions of years, life had remained microscopic. Tiny, single-celled organisms had dominated the planet's oceans, drifting unseen in the vastness of Earth's primordial waters. But in an evolutionary blink of an eye, everything changed. A biological revolution was about to take place, one that would transform the face of the planet forever. This was the Cambrian explosion, the moment when life fought back from the brink of extinction and flourished into complex multicellular forms. The frozen wastelands of Snowball Earth had finally melted. Oxygen levels had stabilized, carbon dioxide had built up, and the climate had become more favorable. In this new, oxygen-rich world, life took its first great leap forward. For the first time, multicellular creatures began to dominate the oceans. Simple sponges and jellyfish-like organisms, which had previously eked out an existence, evolved into something more diverse, more advanced, more alien than anything seen before. The Cambrian oceans became a battleground of survival. Strange new creatures filled the waters, each adapting to the new ecological roles that had never before existed. Among them was Anomalocaris, a giant shrimp-like predator with large grasping appendages and fearsome circular mouthparts designed to crush its prey. It was one of Earth's first apex predators, a terrifying hunter in a world unaccustomed to such danger. Trilobites, distant relatives of modern arthropods, scuttled across the ocean floor. Their hard, segmented exoskeletons provided them with protection, marking one of the first uses of armor in evolutionary history. Some grew spines for defense, while others developed the ability to roll into a protective ball. In response, predators became more cunning, developing better eyesight, faster movement, and stronger attack mechanisms. The Cambrian period had ignited an evolutionary arms race where survival depended not only on strength, but also on adaptation and innovation. For the first time, eyes evolved into highly sophisticated organs. Creatures that could once only sense light and dark now had compound eyes, capable of detecting movement, distance, and even color. With vision came the advantage of stalking prey, avoiding danger, and navigating the complex seascape of this new world. Bizarre, otherworldly forms filled the oceans. Opabinia, a creature with 5 eyes and a long, flexible trunk, sifted through the seabed in search of food. Hallucigenia, a tiny worm-like organism covered in spines, crawled across the ocean floor, its surreal appearance making it seem like something out of a fever dream. The diversity of life exploded, leading to new body plans, new ways of moving, and new forms of predation and defense. But what fueled this sudden surge in complexity? The answer lay in the very thing that had once threatened life itself: oxygen. With more oxygen in the atmosphere and oceans than ever before, energy-hungry organisms could now grow larger, move faster, and evolve more complex structures. The genetic foundations for every major animal group alive today were laid down in this moment. This was the true beginning of the modern animal kingdom. The ancestors of fish, insects, and even vertebrates could trace their origins back to this explosion of life. From the chaotic survival struggle of the Cambrian seas, the blueprints for all future creatures, including one day humans, were being written. But the Cambrian explosion was not just about survival. It was about transformation. Life had fought its way back from the brink of extinction and had emerged stronger, more diverse, and more advanced than ever before. The age of microbial dominance had ended, and the age of complex life had begun. However, Earth's story of mass extinctions and survival was far from over. The evolutionary arms race set into motion during the Cambrian period would only escalate in the ages to come. And while life had taken a monumental leap forward, it would soon face another catastrophic event. One that would shake the very foundation of the planet once again. The Cambrian explosion represents one of the most dramatic periods in the history of life on Earth. Over the course of 3.8 billion years, life on this planet was largely dominated by microscopic organisms, tiny cells that floated in the oceans, barely visible to the naked eye. These early life forms, such as bacteria and simple algae, paved the way for the eventual explosion of complexity in the Cambrian period, a mere blink in the geological timeline. However, by the beginning of the Cambrian, life on Earth was ready to undergo a radical transformation. For the first time, complex multicellular organisms appeared in the seas, setting the stage for one of the greatest periods of biological innovation the world has ever seen. This rapid diversification of life, often referred to as the Cambrian explosion, marks a key moment in evolutionary history, where life forms of unprecedented complexity and variety begin to emerge. The waters that once teemed with microscopic creatures were soon filled with new and bizarre life, many of which would be completely unrecognizable to us today. The seas were no longer dominated by simple cells, but by increasingly sophisticated organisms, each uniquely adapted to its environment, and each playing a role in an intricate web of life that would lay the foundation for future ecosystems. The most notable development of this period was the sudden emergence of predators. For billions of years, life on Earth had been relatively peaceful, with microorganisms simply existing and reproducing in the oceans. However, the Cambrian explosion brought with it the first true predators, creatures like Anomalocaris, a fearsome hunter with large spiny appendages used to capture its prey. These early predators were the first creatures to evolve complex behaviors and strategies aimed at outsmarting their prey. With the rise of predators came the first evolutionary arms race, a dynamic where organisms evolved increasingly complex adaptations in response to the pressures of survival. Prey species developed armor, spines, and the ability to burrow into the ocean floor to escape their hunters. Some evolved camouflage, allowing them to blend in with their surroundings. Predator and prey alike became more specialized, refining their forms and behaviors in response to the pressures of this new, high-stakes world. This explosion of life did not just bring about the appearance of new creatures, it also introduced an unprecedented level of biological complexity. The seas, once dominated by simple organisms, became a battleground where new life forms constantly evolved to meet the challenges of survival. Among the first to emerge were the trilobites, ancient arthropods that became one of the most successful and long-lived species in Earth's history. These creatures were heavily armored, with segmented bodies and a hard exoskeleton that provided protection from the increasing number of predators in the oceans. Trilobites were one of the earliest groups of creatures to develop such a sophisticated defense mechanism, and their presence in the Cambrian seas was a testament to the power of evolution. They existed in various forms, from small scavengers to larger, more aggressive species. Some species, like paradoxides, grew as long as 2 meters, far larger than most other marine life of their time. But it was not just about defense. Life in the Cambrian seas was also about innovation. Some creatures, like the early ancestors of modern-day fish, began to develop more sophisticated ways of moving through the water. For the first time, animals were capable of controlled swimming, a major evolutionary leap that would allow for more complex behaviors and interactions. The seas began to teem with life, and the very structure of ecosystems began to take shape. The Cambrian explosion also saw the development of new sensory capabilities. Eyes, for example, evolved in a number of different forms, allowing organisms to see their environment in ways that had never been possible before. Some of the earliest eyes were simple structures that could detect light and dark, but as time went on, these eyes evolved into highly sophisticated organs capable of resolving fine details and giving creatures a significant advantage in their quest for survival. The evolution of vision also led to the development of other sensory structures, such as antennae and complex sensory hairs, allowing creatures to detect vibrations in the water or the presence of prey. This new level of sensory awareness was not limited to just the predators. Even smaller creatures like Hallucigenia, a spiny, worm-like organism, developed specialized appendages to sense its environment and avoid predators. This period of rapid diversification wasn't just about the physical development of creatures, but also about the development of ecosystems. The oceans were now teeming with a wide variety of life forms, from simple filter feeders to active hunters. The complexity of these early ecosystems laid the foundation for future biodiversity. Species began to fill different ecological niches, and interactions between predator and prey, herbivore and producer, started to shape the way life functioned on Earth. These ecosystems were far more complex than anything that had existed before, and they set the stage for the eventual development of land-based ecosystems, which would emerge millions of years later. However, the Cambrian explosion was not just a time of success and growth. With the increase in life forms came an increase in competition, and this would eventually lead to one of the first major extinction events. Life in the oceans became increasingly competitive, and not all creatures could keep up with the rapid pace of evolutionary change. As the oceans became more crowded and the climate began to shift, some species began to disappear. This period of rapid change would eventually give rise to the first mass extinction event, a dramatic turning point in the history of life on Earth. The increased predation and competitive pressures caused some species to evolve at a rapid pace, while others were simply unable to keep up. The survival of the fittest, an idea that would later define the theory of evolution, played out on a grand scale during this period. Some creatures evolved traits like faster swimming or tougher armor, while others became more specialized in their feeding behaviors. But not all species were equipped to survive. This period of rapid diversification also saw the development of evolutionary dead ends, where life forms reached a peak of adaptation but ultimately could not survive in the changing environment. The Cambrian explosion, however, did not only set the stage for extinction, it also laid the groundwork for new waves of life to evolve. The creatures that survived the Cambrian explosion would go on to become the ancestors of many of the life forms that we recognize today. The first true predators, the first complex eyes, the first specialized behaviors. All of these innovations helped to set the stage for future evolutionary breakthroughs. Life, in all its complexity, would continue to evolve, and the creatures of the Cambrian would leave behind a legacy that still echoes throughout the natural world today. The Cambrian explosion is a reminder of the incredible power of evolution, the way life constantly adapts and changes in response to its environment. It was a time of unprecedented innovation, a period that saw life on Earth take an incredible leap forward. But it was also a time of fragility, as the relentless forces of evolution pushed some creatures to the brink of extinction. This period, in all its complexity and drama, laid the groundwork for the incredible diversity of life that would follow, and it serves as a testament to the resilience and adaptability of life on Earth. The Cambrian period was a time of life fighting back, a time when life on Earth, having spent billions of years as simple microorganisms, exploded into a riot of forms, each more complex than the last. But it was also a time of fragility, as the relentless forces of evolution pushed some creatures to the brink of extinction. This period, in all its complexity and drama, laid the groundwork for the incredible diversity of life that would follow, and it serves as a testament to the resilience and adaptability of life on Earth. As the Cambrian explosion came to an end, life began to spread across Earth in ways never before seen. The seeds of future land-based ecosystems had already been sown, And as life continued to evolve, the Earth would never be the same. The Cambrian explosion remains a reminder of the incredible and unpredictable power of evolution, a testament to how life fights back when faced with ever-changing environments and challenges. The legacy of this explosive period would live on in the life forms that would follow, and in the continuing story of life on Earth. 252 million years ago, Earth faced its darkest hour, the deadliest mass extinction in the planet's history. A catastrophe so severe that it wiped out nearly all life, bringing Earth to the brink of total annihilation. This event, known as the Permian Triassic extinction, would go down as the greatest biological crisis ever recorded. The crisis began with a cataclysmic volcanic eruption in Siberia. For hundreds of thousands of years, relentless eruptions spewed immense quantities of lava across vast swaths of land, creating what is now known as the Siberian Traps. This was no ordinary eruption. It was a flood basalt event, an environmental apocalypse. The volcanic activity released enormous amounts of carbon dioxide and methane, triggering a rapid and devastating change in Earth's climate. As greenhouse gases flooded the atmosphere, global temperatures soared. The oceans, once teeming with life, began to heat up. Warm waters struggled to hold oxygen, leading to massive dead zones where marine life suffocated. Coral reefs, which had flourished for millions of years, bleached and collapsed. The very foundation of marine ecosystems crumbled. But the worst was yet to come. As the oceans warmed, methane trapped in the seafloor was released, further accelerating the greenhouse effect. At the same time, sulfur dioxide and other toxic gases filled the sky, triggering acid rain that devastated plant life on land. The delicate balance of Earth's ecosystems spiraled into chaos. Entire food chains collapsed. Herbivores, unable to find food, starved. Carnivores followed soon after. With oxygen levels plummeting, the oceans became stagnant and lifeless. As marine creatures perished, 96% of all marine species were lost, including trilobites, one of Earth's longest surviving creatures. On land, nearly 70% of vertebrate species vanished. The lush forests of the Permian were reduced to barren wastelands, resembling an alien planet. Earth was suffocating. Massive deserts spread across the continents. Rainforests disappeared. Temperatures skyrocketed, making vast regions of the planet uninhabitable. The air became thick with carbon dioxide, suffocating the land and sea alike. The sky, once blue, was now a hazy orange, choked with volcanic ash and poisonous gases. The planet was on the verge of becoming a dead world, an empty, lifeless rock, much like Mars. The devastation extended beyond life itself. The carbon cycle was thrown into chaos, with excessive carbon dioxide making the oceans increasingly acidic. The once thriving marine ecosystem turned into a toxic wasteland. Gigantic coral reefs disappeared, their skeletal remains dissolving in the acidic waters. Giant predatory fish, armored placoderms, and early ammonites were all wiped out. On land, entire forests burned uncontrollably as wildfires ravaged the barren landscapes. The burning of organic material further fueled the CO2 buildup, creating a vicious cycle of destruction. The once flourishing ecosystems of the Permian were reduced to ashes, and Earth's biosphere was on the brink of total collapse. For a time, it seemed as if life itself had reached its final chapter. But even in the face of total devastation, some species managed to endure. Deep underground, hidden in burrows and caves, a few resilient creatures clung to survival. Among them was Lystrosaurus, a squat, tusked herbivore that became one of the few survivors of the Great Dying. With its ability to withstand harsh conditions and its burrowing lifestyle, Lystrosaurus managed to outlive the apocalypse that had consumed nearly everything else. Small amphibians and early mammal-like reptiles found refuge in the cracks and crevices of the dying world. They endured in the shadows while the surface remained uninhabitable. These survivors would become the pioneers of a new world, a world that would soon be ruled by the dinosaurs. The Permian extinction was the closest Earth had ever come to losing life entirely. For nearly 10 million years, the planet struggled to recover. Entire ecosystems had to be rebuilt from scratch. The first creatures to re-emerge were tough, adaptable species, capable of withstanding extreme conditions. Gradually, life fought its way back, evolving and diversifying once more. From the ashes of destruction, a new era was about to begin, one that would change the course of history forever. The age of the dinosaurs was near. For over 150 million years, dinosaurs dominated the Earth. They grew to astonishing sizes, evolved into diverse species, and spread across every continent. From the towering, long-necked Brachiosaurus to the deadly razor-toothed Tyrannosaurus rex, these magnificent creatures ruled both land and sky. But their reign was not without challenges. Earth itself was constantly changing, reshaping the fate of life in ways both subtle and cataclysmic. The era of the dinosaurs began in the Triassic period, emerging from the ashes of the Great Dying. While life struggled to recover, small, agile reptiles called archosaurs gave rise to the first true dinosaurs. These early species were swift and adaptable, allowing them to outcompete other surviving creatures. Over time, dinosaurs diversified into powerful apex predators and massive herbivores. By the Jurassic period, the world belonged to the dinosaurs. The land was covered in lush prehistoric forests filled with towering ferns and conifers. Gigantic sauropods like Diplodocus and Brachiosaurus roamed in herds, feeding on the abundant plant life. Meanwhile, predators such as Allosaurus perfected the art of hunting in packs, ensuring their dominance at the top of the food chain. While dinosaurs ruled the land, pterosaurs conquered the skies. These ancient flying reptiles like Pteranodon evolved massive wingspans, allowing them to glide effortlessly across vast distances. The oceans too teemed with life, dominated by enormous marine reptiles such as ichthyosaurs and plesiosaurs. But this golden age was not without disruption. Throughout the Mesozoic era, Earth experienced multiple climate shifts, shaping the course of evolution. The Earth's climate during the Age of Dinosaurs was far from stable. Shifts in global temperatures, rising sea levels, and massive volcanic eruptions periodically altered ecosystems, forcing species to adapt or perish. One of the most significant climate events occurred during the Jurassic period, when volcanic activity released vast amounts of carbon dioxide into the atmosphere. The resulting greenhouse effect caused temperatures to rise, leading to the expansion of warm, humid rainforests. These lush environments became breeding grounds for new dinosaur species, sparking an evolutionary explosion of diversity. However, the climate would not remain stable for long. During the Cretaceous period, sea levels fluctuated dramatically, creating shallow inland seas that split continents apart. These new environments gave rise to unique dinosaur species, such as the fearsome Spinosaurus, which adapted to a semi-aquatic lifestyle. At the same time, the appearance of flowering plants revolutionized ecosystems. Previously, dinosaurs fed on ferns and conifers, but the evolution of angiosperms introduced new food sources, reshaping herbivore diets and driving new evolutionary pressures. This botanical shift paved the way for more specialized herbivores, like the armored Ankylosaurus and the horned Triceratops. While the age of dinosaurs was marked by dominance, it was not without setbacks. Throughout the Mesozoic era, smaller extinction events periodically wiped out species, forcing ecosystems to reset and adapt. One such event occurred at the end of the Jurassic period, when changing sea levels and volcanic activity disrupted ecosystems. Many species went extinct, but dinosaurs proved resilient, evolving into new forms that would thrive in the Cretaceous period. Another significant disruption came with the rise of mammals. Though still small and nocturnal, these early mammals competed with dinosaurs for food and shelter. Some developed burrowing habits, others became adept climbers, and a few even evolved gliding abilities to escape predators. These unassuming creatures would one day inherit the Earth. Despite these changes, dinosaurs remained the undisputed rulers of the planet. They continued to grow larger, faster, and more intelligent. Predators like velociraptors hunted with cunning strategy, while giants like Argentinosaurus reached unparalleled sizes. But the world was preparing for its next great test, one that no dinosaur could escape. As the Cretaceous period drew to a close, Earth was changing in ways that spelled doom for the dinosaurs. Massive volcanic eruptions in what is now India created the Deccan Traps, releasing immense amounts of greenhouse gases into the atmosphere. This triggered climatic shifts, causing extreme temperature fluctuations that disrupted food chains. At the same time, shifting continents and receding seas altered habitats, forcing dinosaurs into competition for dwindling resources. Many species perished due to these gradual environmental changes. But the true cataclysm had yet to arrive. On the horizon, a celestial force was hurtling toward Earth, a 6-mile-wide asteroid traveling at unimaginable speeds. What happened next would change the fate of the planet forever, bringing an abrupt end to the age of dinosaurs. The final chapter of their reign was about to be written. 66 million years ago, Earth was thriving with life. Dinosaurs of all shapes and sizes roamed the land, dominating the planet for over 150 million years. Gigantic sauropods towered over prehistoric forests, ferocious theropods hunted their prey, and flying reptiles soared through the skies. The oceans teemed with powerful marine reptiles like mosasaurs, and the apex predator of the seas, the mighty megalodon shark, began its reign. But this golden age of dinosaurs was about to come to a violent and sudden end. Far beyond Earth, an asteroid roughly 6 miles, 10 kilometers wide, was hurtling toward the planet at an unimaginable speed, 45,000 miles per hour. This massive rock, a remnant of the early solar system, had been traveling through space for millions of years. And now, its trajectory was locked onto Earth. There was no escape. As the asteroid entered the atmosphere, it became a blazing fireball, burning brighter than the sun. In mere seconds, it tore through the sky and collided with the Yucatan Peninsula in present-day Mexico, near what is now Chicxulub. The impact released energy equivalent to 10 billion Hiroshima bombs in an instant. The moment of impact, the ground shook with an unimaginable force, sending shockwaves racing across the planet. The asteroid instantly vaporized, creating a crater over 100 miles wide and 12 miles deep. Molten rock and debris were blasted into the atmosphere, igniting wildfires thousands of miles away. The skies darkened as a firestorm of superheated material rained down, incinerating anything in its path. Mega tsunamis, hundreds of feet high, rushed across the oceans, swallowing entire coastlines. The waves crashed deep inland, erasing ecosystems that had flourished for millions of years. The impact also triggered powerful earthquakes and volcanic eruptions, causing the planet's crust to crack and shift. But the worst was yet to come. As the dust and debris filled the sky, it formed a thick, choking cloud that blocked out the sun. Day turned to night. Temperatures plummeted. Plants withered without sunlight, collapsing the entire food chain. Herbivores perished first, followed by the carnivores that depended on them. The mighty Tyrannosaurus rex, one of the last great dinosaurs, succumbed to the famine and chaos. Meanwhile, in the steaming jungles and swamps, another ancient predator struggled to survive. Titanoboa, the largest snake to have ever lived. Growing over 40 feet in length, this colossal serpent had dominated the post-dinosaur world. But even it was not immune to the catastrophe that followed. The world was now a wasteland. The age of dinosaurs was over. After months of darkness, the dust slowly settled, revealing a planet forever changed. More than 75% of all species had been wiped out. The reign of the dinosaurs had come to an abrupt end, making way for the rise of a new era, the age of mammals. In the shadows of extinction, small, resilient creatures emerged, the ancestors of today's birds and mammals. From the ashes of destruction, life would begin again, setting the stage for the next chapter in Earth's history. But for the dinosaurs, their time had come to an end. Earth had narrowly escaped becoming an uninhabitable wasteland like Mars. But life, as always, found a way to endure. For billions of years, Earth has endured cataclysmic upheavals, pushing life to its limits time and time again. From volcanic hellscapes to mass extinctions, from global ice ages to asteroid bombardments, our planet has teetered on the edge of becoming uninhabitable. And yet, life has always clawed its way back. But could the next great extinction finally push Earth past the point of no return? Could Earth, in its distant future, share the same barren fate as Mars? The looming threats. Could history repeat itself? Earth's history is a story of resilience, but also of fragility. The same forces that shaped life's greatest triumphs also orchestrated its most devastating collapses. Today, many of those forces still lurk in the shadows, waiting for the right moment to strike again. Among the greatest existential threats looming over our planet's future are supervolcanic eruptions, climate change, and asteroid impacts. Throughout Earth's past, supervolcanic eruptions have altered climates, driven species to extinction, and plunged the world into darkness for years. The Yellowstone supervolcano, a ticking time bomb beneath North America, is one such potential cataclysm. If it erupts, it could blanket entire continents in ash, trigger a volcanic winter, and disrupt food supplies for billions of people. The eruption of the Toba supervolcano 74,000 years ago nearly wiped out early human populations. What if it happened again on a much larger scale? Then there's climate change. Unlike past events triggered by natural forces, today's climate crisis is largely driven by human activity. Rising temperatures, melting ice caps, and extreme weather events are becoming more frequent, reminiscent of the runaway greenhouse effect that once turned Venus into an inferno. If left unchecked, could our planet spiral into an uninhabitable state? Could we reach a tipping point from which there is no return? And of course, the cosmos remains an ever-present threat. Asteroid impacts have shaped Earth's past, and they could shape its future. The same kind of asteroid that ended the reign of the dinosaurs could strike again. While technology has given us the ability to detect and deflect smaller space rocks, a civilization-ending asteroid remains a possibility. The question is not if another impact will happen, but when. Mars and Earth, a tale of two planets. Mars, now a cold and barren wasteland, was once very different. Scientists believe that billions of years ago, Mars had rivers, lakes, and possibly even oceans. Its atmosphere was thicker, capable of supporting a warmer and wetter climate. But something changed. Over time, Mars lost its magnetic field, exposing its atmosphere to the relentless solar wind. The planet's water dried up, the air thinned, and life, if it ever existed, faded away. The mechanisms that made Mars uninhabitable are eerily similar to some of the threats Earth faces today. Could our planet suffer the same fate? Some scientists warn that if we continue altering our atmosphere, damaging ecosystems, and disrupting the balance that has sustained life for billions of years, Earth could experience a slow descent into desolation. While it might not happen in our lifetime, our actions today shape the distant future of our planet. Despite everything, one truth has remained constant. Life always finds a way. Even after the deadliest extinctions, life has persisted, adapted, and evolved. But unlike past species, we have something they didn't: awareness. We know what threatens us. We understand the science. We have the power to prevent catastrophe. Supervolcanic eruptions might be unavoidable, but with technology and planning, their impacts can be mitigated. Climate change is a crisis of our own making, but also one we can reverse if we act in time. Asteroids remain a cosmic threat, but advancements in space exploration may one day allow us to deflect or destroy them. But the biggest question remains: will we act in time? If we fail to protect our planet, if we continue down the path of destruction, then the future of Earth may not look too different from the desolate landscapes of Mars. A once thriving world reduced to dust, stripped of its life-sustaining capabilities, orbiting the sun as nothing more than a reminder of what once was. Earth has come close to becoming uninhabitable before, but this time the choice is ours. The fate of our world is not yet sealed. Life has always found a way, but will we?